comparison with the theory of relativity. Often, people can be seen comparing Anekantvad with Albert Einstein's theory of relativity, which is not right, as a deeper study of Anekantvad shows that it has its roots much before, and the meaning is way ahead than the theory of relativity. Hence, the latter can be a smaller part of Anekantvad, but not the whole theory itself. In the special theory of relativity, STR, the parameters of motion of an object, velocity, time, spatial dimensions, depend on the frame of reference of the observer and the object. Their motion or acceleration is relative to each other. Hence, when we try to find a similarity between the two, we realize that they match up to a level where it depends on the mindset of the observer while observing and deciding about a specific object or circumstance. We notice that in STR, time and space and motion are not absolute. So does in Anekant. Anekantvad is also compared with relativism, which defines itself. There is no absolute truth, only the truths that a particular individual or culture happen to believe. Whereas Anekantvad says the absolute truth can only be known in its entirety through realization, but it becomes relative as soon as it is described through words. Anekantvad is the main principle that states that everything in the universe has multiple aspects. It can also be understood as the presence of infinite attributes in an object simultaneously, some of which can even be opposite and contradictory. Anekantvad and the uncertainty principle. A fragment of Anekantvad can be compared to the modern-day uncertainty principle, as the latter two depicts the limits of our speculations. Werner Heisenberg's uncertainty principle is about the limitation of the possibilities of knowing. The principle states there is a fundamental limit to which we can know about the behavior of the smallest scales of nature, where the most we can hope for is to calculate probabilities for where things are and how they will behave. Hence, as per the principle of uncertainty, immense possibilities remain to probe further even after having an assumption that we know it all, and so does in Anekantvad. For example, when we try to measure the activities of an electron in terms of its velocity and position without modifying it, even with the best apparatus, it remains impossible to assess the two together. Scientist and author Michio Kaku depicts the Heisenberg's uncertainty principle in the following way. We can never know the exact position and velocity of a single electron simultaneously, no matter how sensitive our measuring devices are. We can know one condition or the other, but not both at the same time. According to Heisenberg, a single electron can be tracked down only in probabilities in terms of its behavior. However, the behavior of the set of electrons can be predicted with the help of uncertainty principle. In the subatomic realm, only probabilities can be calculated. It is impossible to know the exact position and velocity of an electron. It is impossible to predict much about the electron's individual behavior. We can, however, predict with amazing accuracy the probability that a large quantity of electrons will behave a certain way. We need not mention that even an electron has more attributes other than velocity and position, which constantly change. A simpler example of the uncertainty principle is that Central Board of Secondary Education (CBSE) exams are held yearly in India, and over 28 lakh, over 2.8 million students took the exam in 2018. It is difficult to predict a single student's performance, but the board can determine with accuracy the average performance of the students from the entire country. This way, we can have the probability of how millions of students will perform in the exam even before they go through it, but find ourselves unable to predict an individual student's result. In the context of human behavior, one may say that each thought and action first occurs at a subatomic level, and factors like intent, destiny, and free will lay out their future plan. However, uncertainty is always there about what will happen in the near or distant future. For example, not all leaders are good, and not all leaders were always worthy. And also, no one can predict if an average leader today turns out to be a great one in future. Probabilities are always there. In his book, The Logic of Scientific Discovery, Karl Popper expresses, there can be no absolute true scientific laws because our understanding is constantly developing and shifting. Like free will, even in the universe, there are always multiple sets of possibilities, out of which only one can happen at once. This can be termed as the free will of the universe. This leaves us at a point where everything, every thought, every subject, and every object becomes incomplete, relative, interlinked, and philosophical. And we get inspiration to not repudiating previously established truths, but either enlarging upon or refining them. The many-sided nature of truth gives it its strength and indeed its sacred character, which, irrespective of sometimes appearing harsh, is spiritual and keeps us on the track of seeking newer and fresher horizons every moment.